If you think that all the secrets in the universe have not been entirely disclosed, and that some of them we have heard about have not been duly explained and lack elucidation, if you think that there is still a long way to go, if you think space-time may not be the only way the universe is expressed, if you think parallel universes may be feasible, if you want to further your comprehension on this matter, if you believe clarifications of these intriguing mysteries may also be reached through inferences, deductive and inductive reasoning, meditation and introspection, if you understand that Einstein's accomplishment as a physicist also derived from this means of scientific investigation, if you understand that we may mutually exchange viewpoints that may somehow help unravel the uncanny phenomena of the universe, then I would unpretentiously invite you to join us and venture through a pathless and endless land that may render us some rewarding insights. Far from being a scientist, we are a theorist. Theories, and thus principles, do not necessarily imply hard-to-understand mathematical equations, amenable to be interpreted only by experts, by distinguished scientists that have dedicated most of their lives on a certain subject or discipline. Therefore, anyone should be encouraged to partake in discussions concerning compelling theoretical or philosophical issues. Theories and fundamentals are not objectively handled, but rather subjectively conceived to be later on, if consistent, legitimized through experimentation. We do not have to understand Einstein's theory of relativity in every detail to realize that it is a set of principles and that these principles constitute an integrated system called paradigm. Some of its assumptions and principles have underpinned science that is engaged in a much specific, in-depth analysis and practical observations. Science seems to be an endless and pathless land. Relativity has deeply changed our way of visualizing the universe and physics. It has enlightened many doubts that throughout history would be lacking complete elucidation. However, these clarifications are not supposed to be everlasting and comprehensive. As science evolves to meet the complexities and necessities of our daily lives, more and more challenging questions arise. What seemed to be the climax of science evolution shows us that a long path still lies ahead. An endless path with hurdles apparently impossible to overcome. Sometimes our current available scientific means are not enough to explain them, no matter how much we try. Therefore, we need to realize we should resort to new realms of knowledge and inquire into new processes of investigation. We, human beings, do not want to stagnate. It is against our nature. And if that is so, we will need a change of mind, a change of posture, a new orientation, maybe even a complete and bold turnaround. We mean a paradigm shift, a new way of conceptualizing the universe and eventually physics. We have a viewpoint that we would like to share with you by inviting you to advance through the exploration of a new concept. A concept that does not envision our space-time as the only way the universe is expressed, but a way that also transcends tridimensionality. Space-time is an actuality where everything having mass is tripartite. Every object has height, width, and depth, and time is apparently divided into three lapses known as past, present, and future. We strongly believe that some of the odd phenomena in the universe and their intriguing mysteries will not be thoroughly explained in light of space-time alone. The reality of separate things, a reality of forms and shapes, a reality that humankind has always deemed to be the only mode the universe can be visualized and construed, and that mainstream science, although laboriously attempting, has not been able to satisfactorily and fully address it yet. We wish we could put forward the entirety of our paradigm at once by using a couple of words. However, we need prerequisites or basics. What we will try to show is unconventional, something that overrides our human common sense and standard thinking. In this sense, the impossible must be overruled. The impossible is the unknown. Absurdity means intellectual limitation, the unrevealed, our human short-sightedness. Many of our present scientific and technological achievements would be preposterous not very long ago in human history. They would be whimsical, alarmingly unacceptable. Computers that would help us think, that would turn out millions of perfect pictures in a split of a second, would be nonsensical, even to Leonardo da Vinci. We do not expect you, though, to accept everything from the very beginning. Yet we hope you will be indulgent enough to consider it. At this stage of our account, all I would ask of you is to simply absorb what we are to convey without necessarily having to accept it. Comprehension will come about after these prerequisites are attained. It is our claim that some of our common assumptions, long taken for granted, should be reviewed and rethought, such as our sense of sight as being the preferred means for scientific investigations. We should also see the universe as a physically blind man. Our sight is the basis for almost all scientific investigations, and humankind has developed means and tools to enhance it, such as telescopes, computers, microscopes, etc., etc. However, is our sight completely reliable? Is the universe tantamount to our senses? Does the universe equate to our sensorial power? To a certain extent, we may say yes. This is the way we detect things around us, make our judgments, and push forward. However, there are things that do not comply with our common sense. They contradict our expectations and perceptions. They are weird and paradoxical in some instances. Let us name a few. Light constancy. Different objects with different weights hitting the ground simultaneously in free fall. Particles behaving as waves. Instant communication at a distance, etc., etc., that science has treated with utmost consideration, but that has not been able to fully explain. The question is, should we expect the universe and its arcane phenomena to change so that they would match up with our senses and comprehension? Or would it be more sensible that we adapt to its real nature and peculiar manifestations? Obviously, we do not have the power to change the universe. Therefore, it has to be the other way around. We, who are not deprived of the sense of sight, consider ourselves in a better condition to visualize our reality than a physically blind man. However, we are also in a better position to be deceived by outer appearances. At first sight, a well-dressed person, an imported car, an exuberant dwelling may disguise a bankrupted man. Appearances may also give us a wrong description of his intellect, for being grammatically correct will not tell us anything about his shallowness. On the other hand, let us now consider a physically blind man. He lives in a world of colors that he has never seen, shapes and things happening around him that he cannot always detect. However, he survives in this reality. Not only does he survive, but he also fares relatively well. In a certain way, he excels us in many ways we normal people don't. Not only does he excel, but he is also less prone to be deceived by false appearances. When we talk to a physically blind man, he will immediately start analyzing our inner self once he is not influenced by our misleading external aspects. An unbiased, in-depth analysis that will, in most of the cases, tell him who we really are. The same applies to scientific investigation. Experimental researches entail close connection with space-time that we might consider a limited cosmological expression, a limited human way of envisioning the cosmos, and that may also be misleading in some instances. We feel we must grow theoretically for answers that will truly show us what these disturbing and intriguing questions really are, for we believe they transcend our human perceptions. This is our commitment throughout our book, The Superuniverse, Myszko, published by Amazon. This German philosopher once put it like this: we cannot see the universe the way it is in itself. What we can see is the interpretation of our senses. Therefore, we are doomed never to see the real universe, he concludes, for we only see some aspects of it that our senses allow us to detect, and even so, very limitedly. Should we conform to our sensorial limitations? We guess we should not. Humankind has already rehearsed its first steps towards visualizing the universe the way it is in itself, with the formulation of the theories of singularity and black holes. This has not been attained through empirical observation, that means acquiring knowledge by sensorial experimentation only, but by unbiased introspection, thought experiments, deductive or inductive reasoning. This is the way, we should repeat it, Einstein formulated his theory of relativity, that later on was legitimized by the solar eclipse in 1919. His theory that light can be bent by gravity turned out to be true and accepted in the scientific community. The atomic bomb was also the consequence of his theories. So, principles play an important role in unveiling the unknown. It is so generally assumed our judgments would be committed if we did not conduct a close observation on factual occurrences. Factual occurrences meaning an exclusive attention to space-time as the only reality there is. Nevertheless, although incessantly tried, important scientific issues have not been solved, and quantum mechanics shows us that not all our current assumptions comply with the universe nature and our standard thinking. We do not mean that empiricism, practical experimentation, should be abandoned or replaced. We are 3Ds, and this is our condition and our nature. We postulate that what we need is not subtraction, but addition. This being put, we should start out trying to visualize our reality the way it is in itself. Let us start it with a thought experiment. Let us consider this thought experiment. It may shed some light on this issue. In order to stimulate our comprehension on the subject matter here put forth, we will make use of Flatland, a romance of many dimensions, a short satire prodigiously written by Edward Abbott and first published in 1884. Is a profound, enlightening source for those who crave for insight and cosmological understanding. Here is an excerpt of our book, Chapter 23. While satirizing the Victorian society and its standardized ideas, Abbott excites our imagination by depicting a two-dimensional world, a world where any entity can be envisaged as having only height and width. A parallel analogy between our tridimensional reality and this bizarre flatland, these two ontologically distinct realms, will surely instigate reflections on our normal and unique way of visualizing the universe. Since height and width are the only dimensions in this setting, everything, including beings, is flattened like points, lines, geometrical forms, such as triangles, squares, circles, many-sided polygons, etc. Here, each of these creatures enjoys privileges in social hierarchy according to the complexities of their forms. Many-sided polygons being of the highest rank. They too move around, that in their viewpoint should be considered perfect normalcy, although their motion resembles sliding. Our purpose is not to detain ourselves in all compelling points of this worth reading satire, but focus mainly on which concerns a hypothetical bidimensionality and its implications. Although the Flatlanders' actuality differs deeply from ours in one point, we 3D landers and 2D landers share a common problem: the assumption of the cosmos in a supposedly unique framework. In order to stimulate our reflections on this matter and draw some enlightening conclusions as to the universe's nature, we take the liberty of raising two comparative hypotheses. First hypothesis. We could imagine a picturesque situation in which some mischievous earthling, instigated by his desire to create confusion and disorientation to the 2Ds, throws a cylinder that somehow falls upright onto this weird scenario. The question is, how would they see it since they are living in an ambience where objects, for not being tridimensional, are restricted to simple geometrical flat forms? Certainly, they would visualize it partially. They would see it only as a circle. They could only see what was in touch with the surface and thus flattened. Yet, this character surreptitiously snatches this very same cylinder only to throw it back onto this very ambience next day. This time it falls flat on the ground. Probably they would see it as a rectangle. However, the question of real importance is, did they realize they had seen the same object twice, the two occurrences having connection with the same object? We guess not. On the first day, they must have visualized the circle, and on the second, they must have seen a rectangle that is made up of straight lines. Two different occurrences and different geometrical objects. Two completely different things for them. They would never see a cylinder, no matter how much one tried to explain it to them. In much the same way, it is hard for us 3Ds to accept that a particle is actually a wave. We, 3Ds, have the faculty of seeing a circle and a rectangle merged as one sole thing. They do not. Second hypothesis. That very mischievous person, for the sake of amusing himself again, throws, this time, another object onto the scene, a rubber ball. It starts bouncing up and down and around. When it hits the ground, it flattens. When it starts leaving the ground upwards, it recovers its previous shape and size. What do the flatlanders witness? Obviously, they see a circle again. If so it were, there would be no need for commotion. Circles, even circles moving around, are commonplace in that world. Yet, what they would actually see would be something like a circle coming out of the blue, growing in size, shrinking back to its previous shape, then simply vanishing, only to reappear somewhere else and repeat the whole sequence again. It would no doubt be witnessed as a creepy, ghostly scene. For a 3D creature, what happened was perfectly normal. The ball hit the ground, it flattened with the impact and so was enlarged with what was in touch with the surface. And while bouncing up, it recovered previous shape and form only to be, once in the air, invisible for the flatlanders. Even a 3D child would perfectly understand it. However, 2Ds do not. Some flatlander grabs a phone and calls someone that could handle this situation in the best possible way, a well-versed, renowned scientist, 2D Einstein. Briefly, he or it describes what is going on. 2D Einstein laughs quite a bit, as he had never done before. Come on, son. Beforehand, I can guarantee to you that such a thing did not happen, because if it did, it would go against all the laws of physics. Things do not vanish. Things do not inadvertently grow or shrink in size without any cause. Things do not come out of nothing. Yet, upon much insistence that he come and see it for himself, the old scientist agrees. On the spot, where that oddity still goes on, perplexed and awed, for he had never seen anything like that, the old man helplessly gasps in astonishment. Spooky. He could not find a plausible answer that should be consistently scientific. Not willing to give any snappy answers and aware of the responsibility of such statements, 2D Einstein asks for a month term to unravel this mysterious event under strict scientific criteria. 1 month elapses, and here comes our version of 2D Einstein that, to everybody's surprise, is also accompanied by two no less notorious gentlemen, 2D Niels Bohr and 2D Schrödinger. Triangles, squares, circles, and even polygons could not conceal their eagerness to hear them. They could hardly wait for that moment. The answers, underpinned on scientific premise and put forward by such prominent thinkers, should be, beyond any trace of doubt, trustworthy and reliable. Were they disappointed by the prominent scientists? No, they were not. Absolutely. Who, in his sound mind, would ever defy such authorities? Did these gentlemen realize that tridimensionality was the only sensible explanation for the witnessed occurrences? They would never do it, for the simple reason that their universe was conceived to be undeniably bidimensional. Everything being bidimensional made an interpretation also bidimensional. A tridimensional reality was unthinkable. It would contradict their ordinary life and common sense. Therefore, all their efforts to explain the occurrence in question should be linked to their setting. But how are they going to be sensible and at the same time not be coherent with the authentic causes that engender those oddities? By doing exactly what orthodoxy nowadays does in our space-time ambience, making up fanciful, sophisticated, hollow expressions such as the fall of the wave function, the uncertainty principle, the weak force, the strong force, anything, in order to maintain their irreprehensible science alive. By dumping all unsolved questions into a container for future study, in order to sound more scientific, they would also put a sophisticated label on it. And the label would read quantum mechanics, being adamant to accept a new orientation in their investigations. They did not know that this day would never come. They remained imprisoned in their reality. However, in this actuality, there were, as in ours, very peculiar and freaky characters, the so-called pseudo-scientists, whose main purpose and activity was that of turning out outlandish, disgusting theories. This time, they adduced another hilarious assumption. They stated that these occurrences can only be explainable in light of a third dimension. Ludicrous, out of the question, unthinkable, commented the 2D scientific community. We need parameters to make analogies in order to understand some aspects of the unknown physical phenomena. Since we are living in a tridimensional reality, we can figure out what a two-dimensional reality would be like. The notion of a one-dimensional reality or singularity is not easy to grasp, but not entirely impossible. In short, if we know 3, it is because we know 1 and 2. You have preceding parameters. Now, what would it be like if some entity from a hypothetical 7 or 8-dimensional reality attempted to describe its own peculiar world to us? We would never understand it, no matter how much one endeavored to explain it to us. However, we should conclude that no matter how strange or incomprehensible it would, nevertheless, be equivalent to our actuality. 2Ds and 3Ds see the same things differently expressed. Actualities or parallel universes are concomitant and synonymous. They are simultaneous and equivalent. They are the same thing, differently expressed. They all are the unallocated singularity or the one-dimensional actuality. Different expressions of the same thing. All the waves of the ocean are the ocean itself. Quantum mechanics cannot be fully explained in light of space-time or any other hypothetical circumscribed reality. We need a comprehensive cosmological analysis. We need to see the universe as a whole, unbreakable, interacting system comprising all expressions or actualities as one. We need to see the superuniverse.